An interview in core Java, best answered reply. He is dev, dev is getting into core Java interview round. Let's see, how best he reply. Interviewer started by asking,
can you describe Java technology in your words?
Java technology is both a programming language and a platform. The Java programming language is a high-level language that can be characterized by simple, object-oriented, distributed, multi-threaded, robust, secure, etc. In the Java programming language, all source code is first written in plain text files, ending with the .java extension. Those source files are then compiled into .class files by the Java C compiler. A .class file does not contain code that is native to your processor, it instead contains bytecodes. Below is figure. The Java Launcher tool then runs application with an instance of the Java virtual machine. The Java platform has two components. The Java virtual machine. The Java Application Programming Interface, API, it is a large collection of ready-made software components that provide many useful capabilities.
Describe object-oriented programming.
Objects are key to understanding object-oriented technology. Many examples of real-world objects are your dog, your television set, your bicycle. Real-world objects share two characteristics, they all have state and behavior. For example, dogs have state, name, color, breed, hungry, and behavior, barking, fetching, wagging tail. Bicycles also have state, current gear, current speed, and behavior, changing gear, applying brakes. Software objects are conceptually similar to real-world objects, they too consist of state and related behavior. An object stores its state in fields, variables in some programming languages, and exposes its behavior through methods, functions in some programming languages. Bundling code into individual software objects is called object-oriented programming, and it provides a number of benefits, including modularity, that is, the source code for an object can be written and maintained independently of the source code for other objects. Information hiding, by interacting only with an object's methods, the details of its internal implementation remain hidden from the outside world. Code reuse, if an object already exists, perhaps written by another software developer, you can use that object in your program. Pluggability and debugging ease, if a particular object turns out to be problematic, you can simply remove it from your application and plug in a different object as its replacement.
What is class? Explain with real-world example.
In the real world, many individual objects are of the same kind. Let's say, for example, there may be thousands of other bicycles in existence, all of the same make and model. Each bicycle was built from the same set of blueprints and therefore contains the same components. In object-oriented terms, each individual bicycle is an instance of the class of objects known as bicycles. A class is the blueprint from which individual objects are created.
What is inheritance? Explain with real example.
Different kinds of objects often have a certain amount in common with each other. Mountain bikes, road bikes, and tandem bikes, for example, all share the characteristics of bicycles, current speed, current gear, etc. Yet each also defines additional features that make them different. Tandem bicycles have 2 seats and 2 sets of handlebars, road bikes have drop handlebars. Some mountain bikes have an additional chainring, giving them a lower gear ratio. Object-oriented programming allows classes to inherit commonly used state and behavior from other classes is called inheritance. In this example, bicycle now becomes the superclass of mountain bike, road bike, and tandem bike. Extends keyword is used to inherit the property from superclass. Example is given below. A subclass does not inherit the private members of its parent class.
Explain interfaces, why interfaces are used.
There are a number of situations in software engineering, when it is important for disparate groups of programmers to agree to a contract that spells out how their software interacts. Each group should be able to write their code without any knowledge of how the other group's code is written. Generally speaking, interfaces are such contracts. In the Java programming language, an interface is a reference type, similar to a class, that can contain only constants, method signatures, default methods, static methods, and nested types. Method bodies exist only for default methods and static methods. Interfaces cannot be instantiated, they can only be implemented by classes, or extended by other interfaces. Here is an example of an interface. The interface body can contain abstract methods, default methods, and static methods. In addition, an interface can contain constant declarations. All constant values defined in an interface are implicitly public, static, and final.
What are default method and static method in interface, why they are used?
Let's see one situation. A computer-controlled cars publish industry-standard interfaces that describe which methods can be invoked to operate their cars. What if those computer-controlled car manufacturers add new functionality, such as flight, to their cars? These manufacturers would need to specify new methods to enable other companies, such as electronic guidance instrument manufacturers, to adapt their software to flying cars. Where would these car manufacturers declare these new flight-related methods? If they add them to their original interfaces, then programmers who have implemented those interfaces would have to rewrite their implementations. Default methods enable you to add new functionality to the interfaces of your libraries and ensure binary compatibility with code written for older versions of those interfaces. For example, flight, a new functionality is added in below interface as a default. With adding method in computer car interface as a default method, any class implementing computer car previously will not need to modify itself. For example, implement computer car class will not need to add body or modify itself for newly added flight method in below interface as default, but have flight method already if needed can use it. Extending interfaces that contain default methods. When you extend an interface that contains a default method, you can do the following. Not mention the default method at all, which lets your extended interface inherit the default method. Redeclare the default method, which makes it abstract. As shown below. Redefine the default method, which overrides it. As shown below. Static method in interface. A static method is a method that is associated with the class in which it is defined rather than with any object. Every instance of the class shares its static methods. Like static methods in classes, you specify that a method definition in an interface is a static method with a static keyword at the beginning of the method signature. All method declarations in an interface, including static methods, are implicitly public. Example is given below.
Explain instance variable, class variable, and local variable.
Instance variables or non-static fields. Objects store their individual states in non-static fields, that is, fields declared without the static keyword. Non-static fields are also known as instance variables because their values are unique to each instance of a class. Class variables, static fields. A class variable is any field declared with the static modifier. This tells the compiler that there is exactly one copy of this variable in existence, regardless of how many times the class has been instantiated. Local variables have scope locally within a block or method. A method will often stores its temporary states in local variable.
What are all different access modifier?
There are two levels of access control. First is, at the top level or class level, access modifier are, public, package private or default. Other is, at the member level, access modifier are, public, private, protected and package private or default. Top level or class level. A class may be declared with the modifier public, in which case that class is visible to all classes everywhere. If a class has no modifier, the default, also known as package private, it is visible only within its own package. At the member level, different access modifier are. Public modifier, the field is accessible from all classes. Private modifier, the field is accessible only within its own class. Protected modifier, specifies that the member can only be accessed within its own package, as with package private, and, in addition, by a subclass of its class in another package. Package private, member can only be accessed within its own package.
Explain methods overloading in Java.
Java can distinguish between methods with different method signatures. Overloaded methods are differentiated by the number and the type of the arguments passed into the method. For example, in below code. In the code sample, draw, string s, and draw, int I, are distinct and unique methods because they require different argument types. The compiler does not consider return type when differentiating methods, so you cannot declare two methods with the same signature even if they have a different return type.
What are nested classes? Also explain inner classes.
The Java programming language allows you to define a class within another class. Such a class is called a nested class. Example is shown below. Nested classes are divided into two categories. Nested classes that are declared static are called static nested classes. Non-static nested classes are called inner classes. A nested class is a member of its enclosing class. Non-static nested classes, inner classes, have access to other members of the enclosing class, even if they are declared private. Static nested classes do not have access to other members of the enclosing class. As a member of the outer class, a nested class can be declared private, public, protected, or package private.
What is the use of nested classes?
It is a way of logically grouping classes that are only used in one place. It increases encapsulation. Consider two top-level classes, A and B, where B needs access to members of A that would otherwise be declared private. By hiding class B within class A, A's members can be declared private and B can access them. In addition, B itself can be hidden from the outside world. It can lead to more readable and maintainable code, Nesting small classes within top-level classes places the code closer to where it is used.
Explain local classes and anonymous classes.
Local classes are classes that are defined in a block, which is a group of 0 or more statements between balanced braces. For example, you can define a local class in a method body, a for loop, or an if clause. Example is given below. A local class can only access local variables that are declared final. Anonymous class. They enable you to declare and instantiate a class at the same time. They are like local classes except that they do not have a name. These are used when needed to use a class only once locally. An anonymous class has access to the members of its enclosing class. An anonymous class cannot access local variables in its enclosing scope that are not declared as final or effectively final.
What are final classes and final method in Java?
Final method declaration indicate that the method cannot be overridden by subclasses. As shown below. A class that is declared final cannot be subclassed. This is particularly useful, for example, when creating an immutable class like the string class.
What is difference between abstract class and interface?
Abstract classes are similar to interfaces. You cannot instantiate them, and they may contain a mix of methods declared with or without an implementation. However, with abstract classes, you can declare fields that are not static and final, and define public, protected, and private concrete methods. With interfaces, all fields are automatically public, static, and final, and all methods that you declare or define, as default methods, are public. In addition, you can extend only one class, whether or not it is abstract, whereas you can implement any number of interfaces.
Explain when to use abstract class and when to use interface.
Abstract class are used if want to share code among several closely related classes. If expect that classes that extend your abstract class have many common methods or fields, or require access modifiers other than public, such as protected and private. If want to declare non-static or non-final fields. This enables you to define methods that can access and modify the state of the object to which they belong. Interface is used when expect that unrelated classes would implement your interface. For example, the interfaces comparable and clonable are implemented by many unrelated classes. When want to specify the behavior of a particular data type, but not concerned about who implements its behavior. When want to take advantage of multiple inheritance of type.
Is it possible to have class that will not implement all interfaces abstract methods?
Yes. As class that implements an interface must implement all of the interface's methods. It is possible, however, to define a class that does not implement all of the interface's methods, provided that the class is declared to be abstract. Example is given below. In this case, class X must be abstract because it does not fully implement Y, but class XX does, in fact, implement Y.
Explain difference between string, StringBuilder, and StringBuffer.
The string class is immutable, so that once it is created a string object cannot be changed. StringBuilder objects are like string objects, except that they can be modified. Internally, these objects are treated like variable length arrays that contain a sequence of characters. At any point, the length and content of the sequence can be changed through method invocations. Unlike strings, every string builder also has a capacity, the number of character spaces that have been allocated. The capacity, which is returned by the capacity method, is always greater than or equal to the length, usually greater than, and will automatically expand as necessary to accommodate additions to the string builder. As shown in below example. A string builder's length is the number of characters it contains, a string builder's capacity is the number of character spaces that have been allocated. StringBuffer class that is exactly the same as the StringBuilder class, except that it is thread-safe by virtue of having its methods synchronized.
Explain autoboxing and unboxing in Java.
Autoboxing is the automatic conversion that the Java compiler makes between the primitive types and their corresponding object wrapper classes. For example, converting an int to an integer, a double to a double, and so on. If the conversion goes the other way, this is called unboxing. Here is the simplest example of autoboxing. Li is a list of integer objects, not a list of integer value. The compiler creates an integer object from I and adds the object to Li. Converting an object of a wrapper type, integer, to its corresponding primitive, int, value is called unboxing. Example is given below.